When we're maintaining a session, one of the important things is to protect the data that's being sent from the mobile client to the server. And especially if we're going to do something like operate a banking app that's going to be sending data about the person's account to the server and receiving data regarding the balances and the transactions and other things in the account, it's really important that we protect that data in transit. So the very first thing we have to know is that if we have, let's say, a server and we have a client, like a mobile device, that is talking to it over HTTP, particularly if you're talking over some public Wi-Fi network or something else, all of the data in this request is plain text, or should be plain text by default. And what this means is that if there's another attacker who happens to be nearby, or someone who's on the network that can see the traffic going by, they can steal everything that's in this HTTP request. So there are all kinds of tools that are available that are simple to use tools that attackers can download that can readily grab all of your HTTP traffic. So if you ever go and you go to a public coffee shop, let's say, and you log on to the Wi-Fi there, and you begin browsing web pages, and you see that the URL for the web page is something like http:// this is just plain HTTP. And so what you should be aware of is that everything that you send in those requests, what pages you're browsing, all of the data returned in those pages, anything that you send in the body of your HTTP request or in the request parameters, all of that can be intercepted by somebody else. So anytime we just see plain old HTTP as the protocol, we need to be aware that what we're sending is in no way secure and could very easily be grabbed by someone else in the network. Now, that might be somebody else that has access to your wireless network, or it could be somewhere else in the network. So, for example, you may be on a Wi-Fi network that's secured and you are talking to an access point that nobody else has access to, but once that traffic leaves your access point and travels out on the internet, anybody who happens to have that traffic routed by them could look at it and see what you are asking for or what data you're receiving. Now, there is a protocol that can stop all of this from happening, and that's the HTTPS, or the Hypertext Transfer Protocol, the secure version of it. So whenever you see HTTPS, this is no longer plain text, but encrypted. So this is the protocol that we want to use whenever we're going to send really sensitive data that we won't want anybody else to be able to view or intercept. Now, HTTPS is based off of a particular type of cryptography, or the really important piece of it is based off of a type of cryptography called public key encryption. So what we do with this is when you want to communicate with the server gives your client a special encryption key. And whenever your client needs to go and send some data to the server, it encrypts all of the data that it's sending in a request and uses the key provided by the server. And so what this means is that somebody else that's on the network, or someone else that happens to see your traffic pass by them, they can intercept it, but because it's encrypted, it's more than likely that they can't actually read the data that's inside of it. One of the questions you may be asking yourselves is, if the client goes and asks for the key that it needs to use to encrypt the data, how do we prevent somebody else, some attacker that can already see the traffic, from producing its own key that's, let's call it the A key or the attacker key, and we'll call this the R key or the real key? How do we prevent somebody from getting in the middle or performing a man-in-the-middle attack, where when the server sends back the key, the attacker actually receives it, passes a different key to the client, and then when the client begins to go send data, it doesn't know it, but it actually begins encrypting with A key, sending it to the attacker, and then the attacker may forward it on or change it by using our key that's actually meant for the server. So we can end up in situations where we have what's called a man-in-the-middle attack, often abbreviated MITM, and we don't want to end up in a situation where the server returns a key that gets intercepted by the attacker, and then the attacker can substitute a different key. So how do we know that this particular key that we're getting back is really the key that's associated with that server and the one that it wants us to send data with? That's one of the hard challenges that HTTPS helps solve for us. So to solve this problem of an attacker potentially intercepting the key that is going to be used by the client to encrypt the data, HTTPS relies on public key cryptography. Now, the idea behind public key cryptography is that we want to be able to have data that we can encrypt with one key and only decrypt with a second key. And the idea behind this is that we can share a public key with everybody that we want to communicate with us, and if they encrypt data using that public key, then it can only be read by our private key. And similarly, if we encrypt data with our private key, the receiver can decrypt it with our public key. So if we encrypt data with our private key and the receiver can decrypt it with our public key, then they know that it must have come from us, or at least somebody that has our private key. Similarly, if they encrypt data with our public key, then only we can read it because only we have our private key. So another way of thinking about this is an analogy of sort of a mailbox or a lockbox or safe. And the idea behind this is if we put data into it using the public key, the only way, once we've locked the lockbox with the public key, the only way to unlock it is to use the private key. So if we public locks, private unlocks. Similarly, if we put data in here with the private key, so the private key locks the box, the only way to get it out is by using the public key to unlock it. And so what we have is this situation where I can put something in the box and lock it, and somebody can take my public key and unlock the box to get that data out. And this is basically an identity operation. If I can put information into the box and you can use my public key to unlock it, you know I must be the person that put that in there, and the data that was put in there must be from me, because if you used my public key to unlock this box, then you know that that means that I was the one who put the data in there because I used my private key. Similarly, if somebody uses a public key to put that data in there in the box, they know that once they've put that data into the box, the only way to get it out is for me to use my private key. So they can have a confirmation or sort of a faith that if they put data into this box, that only the holder of the private key can then unlock the box to get the data out. And this format is the basis for how HTTPS manages to exchange the keys that are used to protect the conversations between the clients and the servers.